Okay, so now let's go ahead with the software setup to be able to program and play with Soan Papdi. So we use the iStudio, which is available on the internet as well. The only problem is that the release doesn't have changes for Soan Papdi as of today. We plan on landing that in the main software in the future. And once that happens, you wouldn't need to go through all the complicated process or like the number of steps I'm going to describe. All you'll need to do is download the official version and you're good to go. But as I said, that's not the case today. Okay, so once you search for iStudio, this is their official website, the istudio.io URL. And what we are going to do is, just to prove the point, go to their GitHub page, which is github.com/fpgawars/istudio. And then you will notice at the bottom here that the last release they had was June 21st, 2024. And obviously, Son Papdi was conceptualized and realized late 2025. So these binaries here or these release the packages here don't have changes for Son Papdi. Okay, so what I have then done is I have created my own fork of iStudio where I'm currently adding the changes. And once these changes are added, once everything's finalized, they'll be merged into the main repository of Son Papdi, iStudio, and then will be part of the release. Okay, this is the background then. And what we are then going to do is clone this repository locally, my version, which is github.com/streetdog with a double G slash iStudio. And then we'll go from there. Now, what I've done is written a doc that guides on all the steps. So at a very high level, there are two things that we need to remember. So there is iStudio, which is the front end or the GUI, the user interface. And then there is APIO, which is a Python package, the backend, which manages the tool chains and uploading code to the memory of the FPGA board, compiling it, and all of that. So we need to patch APIO to update SoanPapdi related information, and we need to build iStudio from source, so to speak. And none of this is too complicated. I'm going to assume rather that you know how to install Node.js. If you don't, look up a tutorial on YouTube, and you should pretty much be good to go. So you should have Node.js installed because iStudio uses a lot of Node packages. So that's the background. And in general, if you're stuck with something that relates to Node in terms of launching iStudio, well, the minus minus force option should help. That's one thing that I recall on a Windows setup or somewhere I had run into. Anyway, so this is then our first command, which is we are going to clone this repository. And this is again the repository I forked and added the SoanPapdi related changes. So I'm in a terminal here inside of the downloads directory. What I'm going to do is create a directory called sp for SoanPapdi, then go there. And then that's where I will clone this repo. So it'll take a bit and it should be pretty much there. Nice. So once that is done, I'm going to go within the iStudio directory, and you will notice that if I do git branch hyphen a, these are all the branches that are available, and we are right now on the develop branch. What we want to do is switch to the Soan Papdi branch because that's where I have added the changes. So then we do uh, well, we do git switch Soan Papdi, and we are now on the Soan Papdi branch. How do you confirm? Git branch hyphen a, and there should be this asterisk or star right on the left of Soan Papdi. That's when we know that we are working on the right branch. Okay, great. So now we have the software, we are on the right branch, and now what we want to do is call npm, the node package manager, and ask it to install all dependency. Do some run related. Prepare it. We will ask it to fire the prepare job, so to speak, and after that we'll ask it to run the software. So I'm going to throw all the three commands on the terminal and hit the return key. What we'll see is that it'll download a lot of things. and then it'll start the software. Okay, so it's downloading all the packages that it needs, the dependencies. Okay, it's not able to connect, which is fine. Okay, so iStudio is launched. I'll take this because I don't want to see this information over and over again. It is asking me for the board that I'm going to work with. And from the drop down, I'm going to go looking for Soan Papdi. Should be here somewhere, Soan Papdi, right? So one, and by the way, all of this again is detailed in here. It may ask you to select the board, select Soan Papdi. If asked about the toolchain installation, click the pop-up to fetch and install the toolchain. In this case, it will be APIO. Okay, we'll see. So I do this, it says Soan Papdi selected, toolchain not installed, click here to install. Now this is a long process. Um, it downloads a lot of stuff behind the scene and then puts it in the right location. So what I'm going to do is click install. It says, install the stable toolchain. Do you want to continue? Yes. Now this is going to take a while and also ask us for our password a couple of times, like it has asked me now. So I'm going to provide this with my password. So what I'll do now is maybe just pause here and return back once the toolchain is installed. All right, so I'll just catch you in a bit. Okay, so once the toolchain and all the things are installed, it should prompt you about a driver installation. If it hasn't, then you can go here, go to driver, and then be like enable. And what it'll do is now it'll download and enable the drivers for you. So let's go ahead and wait for it to complete that. It takes few minutes, but okay, it says drivers enabled. Great. If you have trouble installing the drivers, it likely is about the permission issue. So you'll need to, like, on your operating system, figure out and resolve that. Only a handful of people have run into it. Um, but just in case you run into that, be sure to resolve it. Okay, great. So so far so good. We now see Soan Papdi at the bottom here. Everything so far great. What we will now do is follow this. So if asked about the toolchain installation, go ahead and do that. If asked about drivers, install that. And now we go to file examples basic number 6. So file examples, well, basic number 6. When we do this, it says that, hey, this example was for this Alhambra 2 whatever board, but do you want it to convert it for Soan Papdi? We say yes. What it does is, the reason it asked is the pin mapping that this example uses was for the other board, and what it is saying is, hey, should I try and work this out for Soan Papdi? Now, when it attempted that, it couldn't find the push button. So you see there's a drop down here with nothing selected already. And in case of LED, it has mapped D6. Now we'll choose D0. And again, what I want to call out is the custom software has these mappings already available. That's the support that I've added in. So here we'll say, hey, and let's actually rename this to switch. By double clicking it, you can change the name. So we want a switch A0 to map to the LED D0, which is right here. So that's the kind of circuit we want to build. We're saying, hey, take the switch, and whatever the value of the switch is, we want it to reflect on the LED. Great. So this is our example circuit. And what we'll now, oh, it has Alhambra selected here. So I'll go to basic, or I'll go to tools, go to, well, let me go to boards and then go down and select Soan Papdi. So we say yes, we want Soan Papdi. Great. So Soan Papdi is right here. It forgot the switch. What is happening? Okay, yeah. So we select A0 and here we select D0. Nice. So ensure Soan Papdi is seen here. The LED is mapped to D0. Switch is mapped to A0. Great. So now we do verify. It says unknown board. Great. So this was expected. So once we, blah, blah, gear icon, it says unknown board. So we have hit the point where APIO is unaware of our board. iStudio is, that's where it gave us the A0, D0, that kind of a drop down menu. And it also showed us this. So iStudio is aware, the toolchain is not. So we are going to patch the toolchain. So once you see this error of unknown board, we are going to go to view command output. So we go to view command output, and here, and the reason we are doing all of this is we want to know the location at which the APIO tools are installed. And so if you see, this is the path. So APIO is available to me in this dot, uh, what is it, dot iStudio slash APIO. On Windows it is different. On Linux it might be similar on Linux. And so what it says is, hey, I did not find the APIO dot INI, and I don't know what this board is. Okay, great. So we only got to teach APIO how to find our board, and then we are through. Okay, so what are we going to do? Yeah, blah, 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 all of this. This is the path of interest to me. And how did I find that out? Well, let's see. So somewhere, there goes. So this is where actually APIO exists, right? So that is the path. So now I'm going to go to this path where the boards.json is, and I need to add the board related information. Now, depending on which Python version you have, this part might change. It might be 3.x. So we're going to attempt, and you're going to attempt going into this path. Well, this path, but this is specific to your machine, and that is what we infer from these outputs. So I will open up a terminal. Let me open up a tab, and I'll cd into, well, let me just go to resources. Just managed to get there, which means I do have Python 3.13 that I'm using. Here, if you see in the resources, there are so many, JSON, or so many files here, and FPGA or boards.json is what we are interested in. So boards.json, and what I'm interested in precisely is adding this information. So I'm going to then go and do like nano or vim, and again, you can open it up. Let me actually open it up in code, boards.json. So this opens up. What I'm going to do is find like the first free slot and paste it there, right? So if you see, all these other boards are defined here. That's how APIO is aware of those. I'm just going to, after the first board definition is finished, I'm going to paste this here. So then let me just kind of do the alignment here, just so that it's readable and nice. Okay, good. So this should be right here. Great. So I then save this file, and that's about it. We are good to go. So I've saved that file. This terminal, I don't need it anymore. We'll see. Save and close. And we come back to command output, close that as well. We are here. Now I press verify, starting to do the verification, and it will take a bit. Um, It'll take a few seconds. Yeah, verification done. Great. So I now press this gear icon, which is for build. So it's now converting the circuit description into a configuration that the FPGA can understand. And where will this configuration go? On the memory, on the board, the flash memory that we have, it'll go there. Let me maybe in the meantime speak about that. Right. So right now the building process, well, building is done. So what it did was it converted that simple circuit, the switch and the LED connection, it converted that to a configuration for the FPGA. Now we are supposed to send that configuration from the USB to the flash memory, which is here, right? And right now the FPGA doesn't have our program or our configuration. So how are we going to do that? Let me simply reduce this in size, bring it over here. Let me have this right here. Okay, so this upload button is the one that we have to press, and then the, the computer will send over the data to the FPGA port. Okay, so when I click the upload, it gives me this. And if you see this, that only means one thing. It's not able to find the board. And the fix to this is very simple. Before we upload or before we decide to upload to the board, we must change the mode of the board to program. And that is exactly why this is yelling at us. So what I'm then going to do is follow this. Oh, well, if I can bring it in the front, right? So we are now going to follow the upload bit stream to the board, and these are the steps that I'll kind of follow now or execute. So let me bring this here. Let me have this in the background. Okay, so to put the board in programming mode, upload mode, we press the PROG button, keep it pressed, and then press and release the reset. And as we release, these LEDs will light up and the board will be in programmable. So now when I hit upload, well, it didn't work. So let's try that again. Okay. So when I now hit upload, that's it. The circuit is uploaded. And then I simply hit the reset button. And now the FPGA is configured to pass the A0 input to D0. So let me then go ahead, and there is A0 right here. If I turn that on, well, guess what? D0 lights up. So congratulations, you've set up the software, set up the tool chain, configured APIO, programmed the board to go into the programming mode, and then uploaded the bitstream. What I'm going to do, just to make the circuit a little more complicated, is I'm going to go to basic. No, I'll go to the left side here. These are the collection manager. And once you click on the collection manager, you have this default collection. I'll go to logic, combinational gate logic, and then I'm going to pick up NOT and simply place in between here. And then I'll just drag and connect the wires. Okay, okay, I created a loop here. Oh God, how do I get rid of this? Yeah, multiple in one. Okay, nice. So just pull it a little on right and things are okay. Great, so this is my circuit now. Whatever the switch A0 value is, I want it to be inverted and the opposite be sent to D0. If this is on, this should be off. If this is off, this should be on. That's the idea. Okay, so verify, build, okay, build is complete, program, oops, it should be in the programming mode. So I press the prog button, press and release the reset button. Now it's in the programming mode, and I hit the upload, and done, the code is uploaded. Now you see, if I press reset, great. So A0 is on, D0 is off. If I turn off A0, D0 turns on. So congratulations, another circuit that's working. Now you're pretty much ready to go ahead and design your own circuit and then upload it to the board and have fun. All right. So with this, congratulations again and happy hardware hacking. Goodbye.